Thanks everyone. Glad to be here. Okay, this one. I'm here today to talk about graphics and PC graphics specifically in Battlefield 3. A lot of PC graphics fans here, I guess? Yeah! Awesome. I'm from DICE, which is a studio in Stockholm, Sweden. Here's a couple of shots of our studio. It's a pretty nice studio we have. That's me up in the right corner sitting working. I like to collect monitors when I'm not, spending. I guess most of you guys have played these games before they're working. How many here have played all of these games? Yeah, okay. Yeah, that's awesome also. So I'm going to talk about BF3. As all of you guys know, it's a 64-player multiplayer game, our big return to the actual true Battlefield experience. We also have single-player and co-op, but for the PC audience, that's usually not that. But they're pretty fun. One thing that's really new and cool about BF3 is that we have this giant, large landscape environments, as well as both urban and indoor environments that I hope you guys will like and see. And we've developed this game for quite many years now, and PC has always been our lead platform, the way we really wanted to design and develop the game for. And in order to do that also, we've added the requirement of having DX10 and DX11 because we're able to write more directly to the GPU, and it's a lot more efficient for us to work in that sense, to really take advantage of all the new features in the GPUs. And in order to create the BF3, we created a new engine, or a new major revision of the engine, the Frostbite engine that we've been working on for quite some time, called Frostbite 2, where we've done some massive enhancements and improvements with regard to both animation, rendering, lighting, destruction, as well as our landscapes and general streaming systems. So it's been a pretty major revision that we've been working on for a long time here, with PC as a focus from the start. But I'm here today to talk about graphics. So let's just jump straight into it. Here we have a pretty fancy screenshot from BF3. This specific part is the single player. This is one reason to play the single player. The graphics there in certain type of environments are really, really awesome. It looks cool in multiplayer also, but it's a little bit different experience in single player, the way you play the game. One important thing when you're talking about graphics though is that most people look at the screenshot and say that has good graphics. Which I hope you guys agree with this screenshot also. Yeah, but it's important to really consider that graphics is really the core portion of the techniques of how you show things on the screen. It's not really what makes a screenshot pretty, or what makes a screenshot visually pleasing. Graphics is the core component here. What we're seeing here is the sort of aesthetic of the picture, that we're trying to build a full picture where everything fits together. So it's not just about the shiny shader or a good lighting effect or a good rain rendering method. It's when all of these things come together, they form a sort of whole and create a pleasing aesthetic of the game. And it was actually a really cool talk, a really cool presentation done a few weeks ago on Penny Arcade about the difference between graphics and aesthetics. Aesthetics is the A here, and graphics is really the way it needs to be the method of serving aesthetics, and also gameplay in our sense. And I think many games are sort of missing this key correlation between aesthetics and graphics, that graphics is really there to improve the aesthetics and the visual style you have for a game, to create a pleasing whole of it. It's not the end goal in itself. And also with gameplay, we see that more and more now. But as we add more graphics, we add it in a way where it actually improves gameplay. Just, you see more, you get better visibility on your levels, you see muscle flashes in dark areas, you actually see those snipers hiding out or things like that. So this is just a core thing I wanted to clear up starting out. But let's jump into the graphics and some of the visual major components that we have in our engine in our game. So I sort of divided up this into 5 major areas that we're going to talk a little bit about, and then finish up with some more stuff. So the first thing is how we handle objects in general in our scene. Objects is a huge portion of everything that you see. Then we also have the lighting engine that we've done massive improvements to create different types of environments. And then the way we do effects, which has always been a big thing for Battlefield. Landscapes and terrain is also another big portion there, and also post-processing that we're working on. So I will go through these individual components and talk about a lot of details in between those. So let's start out with objects. There's really quite a lot of different types of objects we have in our engines and in our game. Every single soldier you see, every single vehicle, every tank, every helicopter, those are very important gameplay objects. Those are really what the game is. You are a soldier, you're controlling a soldier that's shooting on another soldier or a vehicle or a tank or something like that. So those are key gameplay objects. They're really, really important for the rendering and for the game in general. We also have tons of environment objects like trees and bushes in order to create a suitable landscape, as well as man-made objects on certain levels, like buildings, fences, containers, nothing super weird about that. And then effects is another portion also. So, but in order to be able to handle huge amounts of objects on a level, we can have up to 10,000 different types of objects on the level. It really requires a lot of effort in the engine and in the gameplay as well, in order to render that efficiently and handle that and make it fit into memory. Even on a very high-end GPU, we still have a limited amount of memory. So we have some really interesting systems on how to manage the stream meshes and textures. We do LD and distance calling in a lot more expanded way than we've done before. We also have an occlusion calling system, which makes rendering fast by not rendering things that you don't see, which kind of like makes a lot of sense. One thing that's always been strong with Frostbite that we've improved further on is to be able to do parallel rendering, to utilize all the multi-core PCs out there, quad-core or even more CPU cores, to render all the entire world that we have in parallel, and also simulate all the vehicle physics as well as the trees swaying in the wind and all those types of things. So I'm going to talk a little bit more details about a couple of these very important points for the way our engine is improved. So with regard to mesh and texture stream, that's something we haven't really had before in Frostbite or in really any Battlefield game. Previously, you just fill up memory in the engine and then, let that run. And had some graphics options in order to scale it a little bit. But back when we did BF2, we saw that there's some issues with doing that approach. That there's so many different PC configurations, so it's kind of difficult to fill up memory and then hope that works, because there's so many different configurations of memory and of what type of settings that we have. So streaming assets has a lot more flexibility there, because we can overall just reduce the memory amounts that we require to be persistent at, when running. We have smaller sets loaded, so we run on more different configurations. But we can also do it the opposite way. We can increase quality by using that memory in a better way and add a lot more variety in the levels by having tons of unique meshes and unique textures everywhere. This really creates a freedom for our level artists and level designers when they create levels. They don't really have to think that much about, does this fit in memory? They just have to add a lot of content on levels, and then we stream that automatically. And this is something we do both in single player and in multiplayer, and on all platforms. So the way we do this, the core streaming is it's based on not the exact frustum that you're having, the exact viewing direction, because that simply doesn't really work that well on PC. When you're running with the keyboard mouse, you're rotating quickly with the mouse, you can't really stream stuff fast enough for that to work. So we just base it on the camera position, where you are on the level, and the distance to the individual objects and textures, and prioritize that and load it in the background. There's a lot of games that have been doing this for quite some time, and done it reasonably successfully in many games also. But one problem that we've had for a long time in the games industry in general, I think, is that most of these games that have been using streaming has been doing it in DX9, and you can't really do it with DirectX 9 very correctly, because there will be CPU spikes when streaming in new content, because the APIs are not really designed for that approach. So we've been working pretty closely with Microsoft and all the IHVs such as Nvidia to come up with a solution in DX11 where that's actually built into DX11, where you can have a separate thread that creates all your textures, creates all your meshes, and the drivers are specifically optimized for this case that make sure these giant textures that we're loading are uploaded in parallel, so you don't see any CPU stalls based on that. That's really important in order to utilize it quite a lot. So a couple of examples of what we stream. On a multiplayer level, we typically have around 200 and 250 megabytes of meshes That might not sound that much, but if you consider that most people have a graphics card of only a gigabyte, then taking up a quarter of the memory just for meshes, which is just a pretty small portion of the rest of the things that you have, then it actually becomes quite interesting to stream a portion of that memory. And then with regard to textures, there we have a lot more. We have up to 1.5 gigabytes of textures on any single multiplayer level. And while there are cards that have 1.5 gigs of memory, that's not really the norm. People with a lower end card, or even people with a higher end card and running a parallel solution, they can't really fit all that. So that's a major reason why we stream stuff. So these settings are primarily set through the